Welcome to Passlight Insights Academy.
Here we come again. Good morning to you all. Don't forget to like and subscribe to my YouTube channel, and welcome to Passlight Insights Academy. So today we'll be talking about how to balance simple redox reaction. So the first thing you need to understand is that you need to understand the rules that can make you to balance within 2 minutes or 1 minute you are done. So what is that rule? It's Tawai's rule. So this is Tawai's rule. Is the rule that we have in balancing a simple redox reaction. So what is T? We need to determine the type of reaction. What type of reaction we are using here? Is it oxidation or reduction? So these are the two types that we have. Yeah. So number 2, you need to balance the number of atoms. A means atom. Where necessary, make sure you balance. Then number 3 is W. As the case may be, W means water. Have you seen this down? But the question will identify, is it in acidic medium? If it's in acidic medium, so you can have something like this. We have oxygen deficiency, meaning that where there is no oxygen, and we have oxygen surplus, meaning that a point where there is oxygen. So when you have oxygen, or oxygen in this place can mean there is oxygen, or oxygen is more than this oxygen here. So if there is no oxygen here, there is no oxygen, you see that there is no oxygen, though you are adding H2O here, which is water. But a point where there is oxygen, you are adding H+, because we believe that an acid is something that produces hydrozonium, which is hydrogen ion. So anything that produces hydrozonium ion is an acid. Hydrochloric acid is an acid. H2SO4 is an acid. As far as they produce H+. So to identify, even though the question did not identify, and they give you an expression, know that anyway you see H+ is an acid. So number 4, I've done in acidic medium. So the other one are in basic medium. So we are dealing with basic medium now. We are having the oxygen deficiency now, as you can see it. Then we are having oxygen surplus. Oxygen surplus. So in basic medium now, and I told you basic, how will you identify that this thing is a basic? It must produce OH minus. So meaning that a point where there is oxygen deficiency, that there is no oxygen there. So here now we are under basic medium. We have, you see oxygen, there's no oxygen here. See here now, there's no oxygen, we have H2O. Here we have OH minus here. But a point where there is surplus, that there is oxygen there, they have water, H2O, vice versa. Meaning that a point, as you can see on the body here now, H2O, we have it in deficiency here. Here surplus, we have H+, because H+ is an acid. Here H2O, we have it surplus, OH minus we have deficiency, because OH is base. And lastly, let me define last one so that we can move. So the first one now is E, and E means excess electron. Excess electron. So you determine the excess electron and you add it to the appropriate side. So let's start. By the time we start solving them, you understand more better. So let's see. So look at the short video. Number 1, we have to balance Zn to Zn2 plus. So we want to balance this using our Tawai's rule. The first one, determine the type of reaction. That is the first one. So let's determine the type of reaction. What is here? There is no charge. Zinc, no charge. I told you if there is no charge, my charge there is 0. Here now there is 2 plus, so my charge is +2. So is 0 to +2, is it going up or going down? 0 to +2 is going up. So when it's going up now, it's oxidation. Oxidation. So that is oxidation. I'm done with C. Type of reaction, that is the oxidation or reduction. A is a balanced number of atoms. Let's see, zinc here is 1. Zinc here is 1. There is no coefficient and there is no number A. There is no coefficient and there is no number A. So it's balanced. Add water, it's already balanced. So number 3, you don't need number 3 here. Then the fourth one now, let's balance the excess electron. So the excess electron now, E minus means electron, is equals to, you first write minus in between there. This minus is part of the formula. So you have 2, you have 0. So the final answer is 2 electron. Then you add it. What is oxidation? Oxidation is the loss of electron. So what we mean by loss is that it will be added to the other side, gain to be closer to me. So Zn liberated to Zn2 plus 2E minus, thanks. Also, if you have to balance H plus to H2 the same way, just note the first one type of reaction. So let's go with the type of reaction. Is it oxidation or reduction? So what is the charge here? This is plus 1. So what is the charge here? No charge, 0. And we already know that plus 1 to 0 is reduction. So that is the first one. The second one is that we want to balance the atom. Let's see, how many hydrogen is there? 1. How many hydrogen is there? 2. So you put 2 at the back to balance. So you add 2 here. So you're having 2 of hydrogen here, 2 of hydrogen here. So it's going to affect your charge. So it will be 2 open bracket plus 1. Or the 2 you put out is going to affect the charge. So 2 times plus 1, you'll be having plus 2. So plus 2 to 0 is still reduction. So water is already balanced, you don't need W. So go to SS electron the same way. SS electron. So first line minus, and you must not get a negative answer. So what do you have? A 2 minus 0, that is 2 electron. And we know reduction is the gain. Of electron. Is the gain of electron. So we add it closer to myself here. So 2H plus 2 electron liberated to H2 balanced. So these are to balance simple redox reaction in chemistry. If you actually understand my balancing of simple redox reaction, you can as well solve this and put it on the comment section. Let me see. So balance the following: Cl minus liberated to Cl2, and number 2 is that Cu2 plus liberated to Cu. So if you actually understand the first 2 examples that I solved, you can actually solve this, and make sure you drop it on the comment section. Thank you. And please don't forget to like, share and subscribe on my YouTube channel. Thank you.